Hello students. In this video I'm going to show you how to solve polynomial equations and then also how to find zeros and solutions to a polynomial function. So the way we solve polynomial equations, we use all the factoring techniques that we learned in the previous videos in the previous sections. So first thing we try is on the left side of the equal sign or one side of the equal sign, we try to find all the factors of that polynomial. So it's all about factoring again. So we're going to start with the greatest common factor, finding the greatest common factor so that we could then use the zero product property. So here, the greatest common factor in the left side is r, because both of the terms are divisible by r. So factoring out the r, we're going to get 36r squared minus 1 equals 0. Now please recognize that 1 and 36 are perfect squares, so that means this is the difference of two squares. I'll do it on this side. This is the same thing as 6r squared minus 1, so that means this is going to factor into 6r plus 1 and 6r minus 1. So this becomes r, 6r plus 1 and 6r minus 1. And then we use what we call the zero product property, which says that if we have two or more numbers that multiply to 0, that means the first number is equal to 0. In this case, the second number is equal to 0, or the third number is equal to 0. I forgot to put the word or here. And so solving for r, we get one solution. If we solve for r here by subtracting 1 from both sides and then dividing by 6r by 6, we get that another answer is negative 1/6. And similarly, I'm not going to show the work, but r equals positive 1/6 on the next one. So we have three solutions: r equals 0, r equals negative 6, and r equals 1/6. So what do we use here? We use the greatest common factor, and then we use the difference of squares technique. Okay, on the next example, please feel free to pause the video and take notes or think about what I'm doing here. On the next example, we're going to first start by moving that 60x to one side as a positive 60x, because the way we solve polynomial equations is we make one side equal to 0. So 0 on the right side, and then we have 20x cubed plus 8x squared plus 60. You know, I'm thinking about this problem, and I think I copied it wrong, so I'm going to go back and fix it, because the original problem had an 80x squared here. It's supposed to be 80x squared. And so that should have been 80x squared here. And then 60x here. My fault for copying it wrong. So here, what we do is the same thing as the previous one. We always do start with the greatest common factor. Here, what divides 20, 80, and 60 is 20. And notice how they all have, all the terms on the left side have at least one x in common. So we factor out 20x from each of them. And we're going to get x to the second plus 4x plus 3. If you distribute the 20x and multiply it to the three terms, you're going to get the original or the previous answer. So here, the way we factor this trinomial is we think about two numbers that multiply to 3 and add up to 4. And we, of course, need an x times x to get the x squared. 3 and 1 multiply to 3 and add up to 4. So here are all the factors of this polynomial on the left side. So now, by the zero product property, either 20x is equal to 0, x plus 3 is equal to 0, or x plus 1 is equal to 0. If we solve for x in each of these, we're going to get that x equals 0, negative 3, and negative 1 are the solutions. So just refer back to the factoring techniques and then use the zero product property to solve. And that's how you do this. Let's take a look at one more. Same idea. On this one, we're gonna move that y to the fourth power to the left side so that we could have y to the fourth minus 13y squared plus 36 equals 0. Now remember, this is what we call the quadratic form, because 2 times 2 makes 4. Then we could think about this problem, or we could compare it to say x squared minus 13x plus 36 equals 0. So the way we factor this one right here is the way we're going to factor the one with the y to the fourth power. So if we think about the answers to this one here, two numbers that multiply to 36 and add up to negative 13 are negative 9 and negative 4. And of course, we need an x. So this is the way we factor this one right here. So the way we factor the one with the y to the fourth would be very similar. It would be y squared times y squared, because they multiply to y to the fourth. And then we need a negative 4 or a negative 9 and a negative 4. But please notice that this here is just the difference of two squares. So this is going to factor into y plus 3 times y minus 3, y plus 2 for the second parentheses, and y minus 2. And because we're still going to use the zero product property, the answers are going to be either negative 3, 3, negative 2, or 2. So there are 4 answers. There's a way we could check these answers on decimals. If you just type in the left side of this equation and then you look for the x-intercepts, and that's exactly what we're going to be talking about in the next definition here. In a polynomial function, or actually any other type of equation or function, these points right here, these points that I'm going to redraw with red, all of these points, we give them 4 different names. So the way they ask these questions might be different depending on what vocabulary word they use. These points right here, we have 4 different names for them. We call them x-intercepts, because that's when they cross the x-axis. We call them zeros, because that's what makes, that's when the equation is, when the y value is equal to 0, or the y coordinate. We call them solutions. To an equation, we're going to see that in a few minutes. And then and we also call them roots. So if somebody asks you to find the x-intercepts, the zeros, the solutions, or the roots, they're all asking for the same thing. Okay, so just keep these vocabulary words in mind. All of these points, all of these x-intercepts get 4 different names. So if you look at example number 4, it says find the zeros for the function and then sketch the graph of the function. So if we're going to find the zeros, or the y-intercepts, the x-intercepts, we need to figure out when that y value would be equal to 0. So we start by making the function equal to 0. And then we're going to solve this equation just like the previous 3 examples. In this case, I'm going to start off with the greatest common factor, which in this case is x to the second. And then notice that we end up with a trinomial where the leading coefficient is 1. So we're going to factor this by thinking about what numbers add up to negative 1 and multiply to negative 12. So obviously x minus 4 and x plus 3 would work. Now to find the zeros, the solutions, we're going to have to think about the zero product property. So again, when is x squared equal to 0? When is x minus 4 equal to 0? And when is x plus 3 equal to 0? So we're going to have 2 solutions here. Believe it or not, there's 2 solutions. We call it a repeated 0 because there's 2 of them, but we only have to list one of them. We're going to get 4 here, and we're going to get negative 3. So here are the zeros. Now, we are supposed to make a quick sketch of this function, but we know what the zeros are, so we can start by plotting those zeros. We should be doing this with a ruler. So this function is going to pass through 0, 0, 0, positive 4, and negative 3. Then we could use quite a few things here. For example, we know that this polynomial function is the degree is even and the leading coefficient is positive here. So we know that this polynomial function is going to have an end behavior that looks like this. End behavior. Because the degree is even and the leading coefficient it's positive, that's how we know the end behavior is going to look like that. So this graph is going to do this, it's going to do this on this end, and it's going to do this on this end. Later on, we're going to explain how this repeated 0, because it repeats an odd number, an even number of times, this graph is going to come down, it's going to hit the x-intercept, the x-axis is going to bounce back down, and then it's going to go back up. So just to double check that my graph right here kind of makes sense, I am going to go now and show you on Desmos how this actually makes a lot of sense. So here we go. And this is a function that we had. And notice how if I zoom in, this graph kind of makes sense where we have our x-intercepts at -3, 0, and 4. Okay, so going back to the notes, let's go ahead and do our final example here. So since we're finding the zeros, we're going to find out okay, my pencil doesn't want to work. We're going to let the function equal to 0 so that we can find out what the zeros are. And this is what we have. Please remember how to factor a polynomial function that has 4 terms. We do it by grouping. If you remember, step 1 is to group. So the first thing we do is group. Second thing we do is we take the GCF on each group. So here the greatest common factor, the greatest common factor would be x squared, and we're going to end up with an x plus 4. And we're going to find the greatest common factor on the right parentheses is -6. And so this here is x, because the next thing we do is we factor out the common factor. You see, factor the common factor. So x plus 4, parentheses x squared minus 6. You see that? X squared from here, minus 6 from there. And we're still trying to figure out when that is equal to 0. So either x plus 4 equals 0 or x squared minus 6 equals 0. Obviously, x equals -4. And the way we solve this, if you remember from your previous math classes, we take the square root on both sides and we add plus or minus. So x equals plus or minus the square root of 6. The square root of 6 is approximately 2.45. So that means that on the graph, since we're making a sketch, and then we're going to check it on Desmos, the zeros are x equals -4, x equals the square root of 6, and x equals negative square root of 6. So at about 2.4, and about 2.4 on the negative, and at x equals -4, it looks like I run out of space. say negative 4 is here. This graph is going to pass through here, here, and here. But again, looking at n behavior, the degree is odd and the leading coefficient is positive. So this n behavior is supposed to do this. You could even go ahead and find some points on the graph by substituting x equals 1, x equals negative 1, x equals 2, x equals negative 2, and so on to make it more accurate. This graph is going to do the following. It's going to go through here, come back down. It's probably go down a lot, and then it's going to go up. And since we're just doing a quick sketch, I think that is good enough. Take a look at the equation. I want to check it graphically on decimals. And let's see how accurate we were. Okay, so selecting the right graph since I already had it here. Notice the x-intercepts are negative 4. Oh, it looks like I typed in the wrong function. Okay, so just disregard this last example or last part of the graph. We could go back and type in the right equation here. I had the wrong one, but you're gonna see that it makes sense graphically if you check this on decimals. Please check it and then review these notes. I'll see you next time.